Welcome to qnawire.
Okay, we have got the following molecule. Cyclohexane with an axial bromine here and an axial chlorine here. All right. And the first thing we need to do is give an IUPAC substitutive name of the compound. I personally would find this easiest to just redraw it from the top down. So I've got a cyclohexane. Let's call this carbon 1, 2, 3. And I'm going to consider taking this and flipping it on its back so that bromine is pointing up at me and chlorine is pointing up at me. I don't know why, but that's just the easiest way for me to think about it. The bromine here on carbon 1, 2, 3, and then chlorine here on carbon 3. Okay. Put a proton there and put a proton there. And then we'll start considering the stereochemistry. Okay. So I'm going to start by labeling the priority of these various substituents. I see that bromine is the highest priority substituent on carbon 1. So I'll put a 1 next to that. The next highest priority is this carbon on the right because it's bound to a carbon that has a bond to a chlorine, whereas on the left, it's just a bond to a carbon with 2 bonds to hydrogen and 1 bond to carbon with 2 bonds to hydrogen. So the right-hand path hits chlorine sooner. And now I've got hydrogen in the back, or the lowest priority group in the back, which means I can just determine whether connecting 1 to 2 to 3 happens clockwise or counterclockwise. This looks clockwise to me, so it's R. Okay, and for the chlorine, let's go ahead and label the substituents in terms of priority. Chlorine is going to be 1. And this carbon is going to be 2 just because it's closer to bromine than the other one. And then we get 3 for the remaining carbon. The lowest priority substituent, hydrogen, is in the back, and this looks counterclockwise to me, going from 1 to 2 to 3, which tells me that this is S. All right. So now we just have to put that information together. Our highest priority group is bromine, so we're going to name this carbon 1. And then alphabetically, bromine will come before chlorine, so it's going to show up first in the naming. And then recall that we'll have to enter the stereochemical information in for the name as well. So before we write anything, we need to indicate that this is 1R, 3S. Okay. Then we can start in on the rest of the name. We know it's 1 bromo and 3 chloro, and it's cyclohexane altogether. Okay, so that's the IUPAC name with stereochemical designation. Okay. Now, given that halogens have the same degree of bulkiness, the most stable conformer is, and then we're going to have to draw the ring flip conformer. We're shown one form and we need the other. Let me make a little space here. Okay. Now the way I do this is if the lines are going parallel this way, the first time I make the lines going parallel that way for the ring flip conformer. And then typically what I do is whatever carbon is up here, that's going to be right there. Right, so I relate the top right-hand corner carbon to the bottom right-hand corner carbon in the ring flip conformer. Okay, let's finish drawing this. So that means this is carbon 1, this is carbon 2, and this is carbon 3. Just for illustrative purposes, I'm going to add the hydrogens to this first conformer. We've got an equatorial hydrogen there, and we've got an equatorial hydrogen here. Okay, So on carbon 1, we know that the axial substituent then should be straight up, and that it should be hydrogen, because in the other conformer, hydrogen was equatorial. And then our previously axial bromine will now be equatorial. Okay, and on carbon 3, our previously axial chlorine should be equatorial, and our previously equatorial hydrogen should be axial. Great, so that's our ring flip conformer. Which is more stable? Well, recall that anytime you've got axial substituents besides hydrogen, they're somewhat bulky and they will interact with each other. If you have bulky substituents, it's preferable to have them equatorial because there's nothing much for them to bump into out there. So in the first conformer, all of our bulky substituents, chlorine and bromine, are axial, which is not energetically favorable. And the second conformer, all of our bulky substituents are equatorial, which is favorable. So the lowest energy or the most stable conformer is the one where both of our bulky substituents are equatorial. So that would be the ring-flipped conformer. Okay, finally, in the conformation shown at the left above, select the position occupied by the bromine. Is it axial or equatorial? It is axial. We've kind of already discussed that. Okay,